Imagine an ordinary afternoon. Not a hurricane. Not a war. Not even a particularly strange day by the standards of the world you live in. The sun is out. Animals are doing what animals do, eating, resting, chasing each other through green undergrowth. And within the space of about a day, more than 70% of every species on Earth will be gone. No warning sirens. No storm on the horizon. No sense anywhere in that ecosystem that anything unusual was coming. How is that even possible? How does an entire living world, full of creatures that had survived droughts, ice, disease, and each other for millions of years, simply fail to see the end coming? That's the real mystery hiding at the center of the story we think we already know. Not the extinction itself. The absence of any warning at all. Most people, when they picture the end of the dinosaurs, picture something almost cinematic, a slow, dawning realization. Skies darkening for days. Animals fleeing in panic, sensing doom on the horizon the way a herd senses an approaching storm. It's a comforting version of the story, in a strange way, because it gives the animals some agency. Some awareness. A chance, however small, to see it coming. That version is almost entirely wrong. For most of the ecosystem, on that final ordinary day, there was no gathering dread. No shift in animal behavior for weeks beforehand. No mass migration away from danger. Because the danger wasn't something built up gradually, the way a famine or an ice age creeps in over generations, giving animals time to adapt or flee. It arrived, essentially, all at once, faster than any nervous system on the planet could have processed it as a threat. Here's the detail that changes everything about how we should picture this moment. Researchers studying the impact site off the coast of what's now Mexico have been able to estimate, with startling precision, how quickly the asteroid moved through the atmosphere before impact. It wasn't slow enough to see coming and understand. It was traveling at somewhere around 12 miles per second. At that speed, the object went from being a point of light in the sky to a global catastrophe in less time than it takes to react to a loud noise. Which means, for the vast majority of animals on Earth that day, there was no window for fear at all. Fear requires time. Time to notice a threat, time for a signal to travel from eyes or ears to brain, time for a decision to run or freeze. The asteroid didn't give the world that time. It's one of the only mass death events in the history of life on Earth where the dying began before the danger could even register as danger. Let's sit with that for a second, because it's stranger than it first sounds. We tend to think of extinction as something that happens to a species over time, populations shrinking, generations struggling, individual animals sensing that something is wrong. This wasn't that. For the animals closest to the impact, there wasn't a wrong to sense. There was simply a before, and then, almost instantly, an after. This is where the story starts to twist in an uncomfortable direction. Because if the animals near the impact site never had time to process the threat, the ones farther away had something almost worse. Enough time to notice that something had changed, without ever understanding what it was, or how bad it was about to get. Picture a triceratops herd, hundreds of miles from the impact site, going about an entirely normal day. At some point, faintly, there's a flash on the horizon, bright enough to notice, strange enough to make heads lift and ears, or whatever a triceratops used to sense its environment, prick toward it. And then, nothing. No immediate danger. No visible threat. Just an unusual light in the sky, followed by an equally unusual silence. There's no reason, based on anything in that herd's evolutionary experience, to interpret that as the beginning of the end of their entire world. Nothing in their instincts, built up over tens of millions of years of dinosaur evolution, had prepared them for extinction-level event. Their fear responses were built for predators, for storms, for floods, threats with a shape, a direction, something you could run from. This had no shape. There was nothing to run toward or away from. The danger wasn't a predator stalking through the underbrush. It was the sky itself, quietly rearranging the rules of survival for every living thing beneath it. This is where the science gets almost eerily specific, and worth sitting with before we move forward. In the hours and days following impact, researchers believe the immediate blast and heat wave killed enormous numbers of animals within a radius of hundreds, possibly thousands, of miles. But here's the detail that should genuinely unsettle you. For animals just outside that radius, death didn't come from the blast at all. It came from something far stranger, a rain of superheated debris, flung high into the atmosphere by the impact, falling back to Earth as a kind of global firestorm. Forests around much of the planet may have ignited, not from a spreading wildfire moving across the landscape in a way animals could flee from, but nearly simultaneously, ignited from above, all at once, everywhere the debris fell. Which means, for a huge portion of the animals who survived the initial blast, the second wave of death didn't behave like fire ever had before in their evolutionary experience. Fire, to any animal on Earth up to that point, was something you could see coming, smoke on the horizon, heat building gradually, a direction to run away from. This fire came down from the sky itself, in every direction at once. There was no way. Let's slow down here, because this is where the story stops being simply about geology and starts becoming something closer to unbearable. Even for the animals who survived that first day, and many did, tucked into burrows, sheltered by water, simply lucky in their location, the story doesn't get gentler. It gets slower, and in some ways, stranger. Because the true killer, the one responsible for wiping out the vast majority of species over the following months and years, wasn't fire or heat at all. It was darkness. The impact is believed to have thrown enough dust, soot, and debris into the upper atmosphere to block sunlight across the entire planet for months, possibly longer. Which means that for animals who survived the initial catastrophe, who had, in a very real sense, made it through the worst day imaginable, the sun simply didn't return the next morning. Or the morning after that. Plants that depended on photosynthesis began dying in a matter of weeks. Which meant the animals that ate those plants began starving. Which meant the animals that ate those animals began starving too, working its way up through every level of the food chain, one empty stomach at a time. Here's the part that should stay with you longer than the fire, longer than the blast itself. Imagine surviving the single worst day in the history of life on Earth, only to spend the following months watching the world slowly go dark and silent around you, with absolutely no understanding of why, and no instinct built for a threat like, the sun isn't coming back. There was no predator to fight, no flood to escape, no storm to wait out. Just a steadily emptying world, and a body growing hungrier every day, with no biological framework for understanding what was actually happening. This is where the story forces us to ask a harder question than, what killed the dinosaurs? It forces us to ask, what does survival even mean, when the thing killing you isn't a creature, or a place, or a moment, but the absence of something you never had to think about before, because it had simply always been there? There's a particular detail from a fossil record that captures this slow unraveling almost perfectly. In certain post-impact sediment layers, paleontologists have found evidence of a strange, temporary boom in fungi and fern species, plants that don't need direct sunlight to survive in the way most flowering plants do. In the immediate aftermath, while the sky stayed dark, ferns and fungi briefly took over landscapes once dominated by lush, sunlight-hungry vegetation. Scientists sometimes refer to this layer as the fern spike. Which means, in the strange arithmetic of that extinction, some of the biggest winners in the short term were among the least glamorous organisms on Earth. Not because they were smarter, or stronger, or better adapted in any dramatic sense, but because they simply didn't need the one thing that had suddenly vanished. Here's the twist that should reframe everything you think you know about who deserves to survive a catastrophe. It wasn't the biggest animals. It wasn't the fiercest predators. It wasn't even, in many cases, the most intelligent creatures roaming that world. Survival, in the aftermath of that single unimaginable day, had almost nothing to do with strength, speed, or dominance. It had to do with something almost embarrassingly simple: how little you needed, and how quickly you could adjust to needing even less. Small, burrowing animals, many of them ancestors of modern mammals, appear to have fared dramatically better than the giants that once ruled the same landscape. Not because they fought off danger better. Because their bodies required less food to survive a famine that lasted years. Because many of them could retreat underground, sheltered from both the initial heat and the following cold. Because being small, unremarkable, and metabolically modest turned out to be one of the greatest survival advantages evolution had ever accidentally produced. Which means the animals we tend to imagine as weaker, the small mammals scurrying at the feet of dinosaurs for the previous 100 million years, weren't actually weaker in any way that mattered on that particular day. They were simply built for a different kind of world than the one that had just ended, and it happened, by pure chance, to be exactly the kind of world the aftermath demanded. Let's go even deeper into what this actually might have felt like, as much as the fossil record allows us to imagine it. For a surviving tyrannosaurid, or one of the last remaining large herbivores clinging to existence in the following months, there would have been no single moment of realization. No sense of, this is the end. Just a slow, grinding decline. Less food each week, fewer of your own kind encountered on each journey across a darkening, increasingly silent landscape. Animals whose entire evolutionary strategy had been built around dominance, size, and power found themselves in a world where none of those traits mattered anymore. The very things that had made them successful for millions of years had nothing to offer against an enemy with no body, no location, and no way to be fought. There's something almost unbearably human in that image, if you let yourself sit with it. Because we like to imagine collapse as something dramatic. A single battle, a single villain, a single moment where everything visibly changes. But the ending of an entire world, for most of the creatures living through it, looked instead like a long, quiet tightening. Less food. Fewer neighbors. A little darker each week than the week before. No enemy to blame. No warning that would have helped, even if it had come. This is where the story stops being only about dinosaurs. Because every dominant form of life that has ever existed on this planet, not just the animals of that particular Cretaceous afternoon, but every species, every ecosystem, arguably every civilization, has operated on an unspoken assumption that the fundamental conditions of the world they were built for would keep existing. Sunlight would keep arriving. Seasons would keep cycling in familiar patterns. The rules, whatever they were, would hold. The extinction event that ended the age of dinosaurs is really a story about what happens when that assumption turns out to be wrong, all at once, with no negotiation and no warning. And here's the detail that should sit with you longest. Nothing about that day required intelligence, or awareness, or foresight to survive. It required, almost entirely, the accident of already being built for a world you didn't yet know was coming. We don't know, of course, whether any individual dinosaur understood, even in some dim, non-human way, that the ground beneath its species was shifting in those final months. Almost certainly, none of them did, in any way resembling comprehension. But the pattern their extinction reveals, invisible threats, sudden collapse, the strange randomness of who happens to be built to survive change they never saw coming, is one that echoes far beyond that single Cretaceous afternoon, into every extinction, collapse, and disappearance that has followed it since. There's a fossil bed, not far from the actual impact site, where researchers have found a layer of preserved life caught in the exact transition between the old world and the new, plants, small creatures, fragments of the ecosystem, frozen in sediment at the precise moment everything changed. Scientists sometimes describe it as one of the only places on Earth where you can, quite literally, put your finger on the boundary between one entire era of life and the beginning of another. Not a war. Not a slow decline anyone could have prepared for. Just a line in the rock, thinner than a fingernail, separating a world that had one set of rules from a world that would need an entirely new set to survive in. So the next time you picture the end of the dinosaurs, don't picture panic. Don't picture a herd sensing doom on the horizon, given time to understand what was coming. Picture, instead, an ordinary afternoon. Animals doing ordinary things. A flash of light most of them never had time to interpret as anything at all. And ask yourself the question this story keeps circling back to, whether you're thinking about ancient ecosystems or something closer to home, if the end of an entire world can arrive without ever announcing itself, what makes any of us think we'd recognize the warning, even if it came?